I'm Steven Soroka. I've been doing Go for probably about 5 years now. I was doing Ruby for 10 before that, so I've been writing software for a long time. You can send feedback to me at @soroka if you like on Twitter. You are welcome to interrupt the talk to ask questions throughout. I'd like it to be a bit of a conversation. I definitely don't have all the answers. This is really just from my perspective. If you want to come work with me, that'd be cool. Okay, so outline, I'm going to throw out a lot of ideas. Some of them might be a little bit much to absorb all at once, and I think it's just the way it is. This is kind of my perspective from like as a minimalist at a startup, and from somebody who doesn't like complexity. So, okay, with that in mind, I'm going to talk about what is validation, what kind of things should we validate, why should we validate things, what are good implementations for validation libraries, and for some definition of good, extending your validator, and going down this route, what can you build on top of this, and what future options do you have? Okay, so what is validation? What's our definition of validation? The data is in the expected format. This value is allowed. This includes bound checking for, I'm not expecting negative integers. I'm not expecting integers over 1 billion. I'm not expecting strings of 6 gigabytes, whatever. Is this a valid user? Isn't really in the domain here. It's more of an authentication thing. Does the user have access to this? That's really authorization or access control. So that's not really what I'm talking about here. The canonical example of email validation seems to be validating emails. So if any of you have done email validation, which I'm sure all of you have, you'll feel some of this pain, I think. And I'm just going to take a short tangent on this. Okay, quick quiz. Which of these are valid email addresses? The answer is all of them. According to the RFC 822, which defines emails, the RFC sucks. These are all valid email addresses. It's ridiculous. The integer second from the last is an integer representation of an IP address. It's kind of ridiculous. Most of you probably, if you've implemented some kind of email validation, have written maybe something in maybe gone simple and just checked to see if there's an @ sign. It's not as bad as it sounds. Maybe some of you went complex and tried to write a regular expression to validate it. This guy did, and this monstrosity was generated from Perl, a program in Perl that generates the regular expression from other similarly complex rules. This answer is about 6 kilobytes in size. He notes that, the author notes that it doesn't even implement the entire RFC 822 spec. He left out support for comments in email addresses. You didn't even know email addresses supported comments, did you? Not only that, it supports recursive comments. I don't know why that's ever needed. The RFC 822 spec was written in 1982, so I don't know, they had different ideas. Probably if you're going to validate email, just like with regular expression, just do like .plus at .plus. I mean, that will probably be most reliable. There's actually a good package that you can use, which does it mostly right. It kind of splits email validation into 3 separate pieces. One is a regular expression, which you can replace with this one. And the other 2 are, it splits the @ sign and looks at the domain, does a DNS lookup, which is a reasonable thing to do. Checks to see if it can actually contact the server, and then asks the server about the username part of the address. And if the server says this user doesn't exist, then the email address is not valid. If it says, yes, this user exists, then the email address is valid. If it says, I don't know, which a lot of mail servers do to avoid spamming and like scraping of email addresses, the majority of them actually don't give you an answer. You just assume that it's valid. So this package is good if you need to do that.
It's kind of a costly email check.
It is a costly email check. It depends. Yeah, absolutely. It depends what you need for email validation. Again, if you're doing thousands per second, maybe you just want the top one. Or maybe not even. OK, so back on track. What do we want to validate? We want to validate requests. Incoming requests we want to validate for our services because we don't trust the clients and the inputs we get from them, or we shouldn't. We can validate our models. We have business logic in our application. Usually half of it's implemented in the database. I kind of like the idea of having your application being your canonical source for validation. So with the exception of maybe uniqueness checks, like uniqueness on an email address or uniqueness on an ID or something. Moving those validation checks into the application and having the application enforce that. If you've ever tried to modify a table in a relational database with heavy constraints set up on it or lots of foreign keys, you can easily run into a situation where you have to roll them all back before you can modify the schema and then reapply all your validation on top of it. So it's not really that great, that scalable of a solution. So this is some of the reasons I like putting it into the application. Also, like if you have a command line thing, validate the command line arguments. Are you getting the arguments that you expect? Validate your file formats and your config files and make sure that the things that are inputting data into your application are in the format that you expect. This is actually a huge source of bugs for image processors, web services, and stuff. Like every buffer overflow ever is a missing validation. So why validate? Well, client-side validation. This is a funny image of a client-side validation. Client-side validation is a keep-out sign. It's it only works for the people who are listening to your sign. So yeah, why validate? We don't want to trust the inputs. Clients can be buggy, out of date. They can be malicious. That's thank you. They can yeah. So lots of buggy apps, missing values, old values, all kinds of things. Huge inputs. If you don't have limits on the sizes of the data that you accept, especially in the case of maybe your backend database is a key value store. You haven't thought about implementing size constraints on some of these things. If you blindly trust the inputs, save them to the database, I can submit requests to you 2 gigabytes a piece until your disk is full. So it won't take long to bring your service down like that. And then there's script injection, SQL injection. You can get rid of these pretty easily by just saying, what are the set of valid characters that I accept for this input? And of course, maintaining your database, your data integrity on the model side. So I'm going to look at a couple implementations of different validators that are written in Go that you might want to use in your project. I've sort of grouped them into a couple groups and selected a few of them that I thought were worth talking about. Basically, the different types are one-off validators. They'll have a function that you can call, and it returns you a true or false or an error message if it's not valid. There's field tags we'll look at, struct validators, and I might touch a little bit on the last one. Okay, so the first one here is I'm not going to try and pronounce it. Go Validator here. It's basically, there's more in this package, but the majority of the value here is there's a huge list of validator functions. So he's written a lot of them already. Even if you wanted to build something else, you might want to import his packages to build on top of it. So they're really easy to use. Is this an email, yes or no? Field tag validators take the idea that we want to implement the validation as field tags. And let's stick all the validation rules into a field tag. There's some issues with this, I feel. You've probably already got JSON tags in here. You've maybe got DB tags in here. Maybe you've got other stuff in here. It gets to the point where this, I feel, is not as maintainable. There's also, well, this regular expression looks a little bit suspicious. Like, how is it going to handle commas and escaping? I feel like I'm, trying to code through a glass of water or something. It's kind of weird. But it's easy to use. You call the validator validate function, pass in your object, and it returns an error if it's not valid. This is another field tag validator. You can see they've got a little bit different ideas about how to pass, arguments to some of the validators there and pass multiple validations to it. It calls it similarly. I think one of the interesting things is that you can cast the error back to like this validation errors thing, and it's a map of errors, a map of string to error, so you can get all the individual errors for each field, which is really useful for passing back to the client, because then the client can say, oh, I had an error on this specific field, and now it can go back in and highlight that field, ask the user to update the value. The downside of these, the field tags, is that you get no code completion help. Your editor's not going to be any assistance to you. You have to go diving into the package if you want to get any information about what's supported, and you just kind of have to remember it. I think it's going to get messy really easily, really quickly. There's support for custom validators, but not really support for complex arguments, not easily anyway. And you lose your type safety, so that kind of sucks from type safe language. My validations aren't type safe. Okay, I don't know. So let's go to Struct validators. This guy's Ozzo's sort of like, I don't know, I think he's building a framework, and he had the really nice thought to build validation as a standalone thing, and I think he actually took a really an approach that's really close to what I would have built. This is an example of validating a simple string. It's broken onto multiple lines just so it's easier to read. But validates the string. Can validate that the field's required, that it has a length between these arguments, maybe that it's a URL. Obviously that one's going to fail. Maybe. This is nice because you can discover functions really easily. I mean, you can go to validation dot, hit your code completion, and it'll give you a list of all the functions that you can add. It's type safe. Yeah, let's take a look at how you might use this on something more complex. So maybe you have an address struct and you want to implement validation for this. What you can do is define a validate function on your address struct and call the validation library. So it's kind of a lot to fit on the slide, so I'll just break it out here. So we've got the, you're defining the function on the address. You call a validation validate struct, passing in the address instance, and then validate each field on the struct. So the rules get passed in as arguments. So these are the validation rules, like this field's required, has to be this length. It supports regular expression matching, although in this case I don't think you should validate regular province list with regular expressions. You should probably have like a string and list validator or something. There is support for extending it with custom validations, although really I think string and list should be built into the validation framework. Postal codes. Is there a question? Okay, sorry. I like questions. Okay, so that's the whole thing. if you alias the validation package, the whole thing gets a lot easier to read. Putting the validation dot everywhere is kind of verbose. And then using it's, again, really simple. You create your address and you ask it to validate itself. Returns errors if there's any validation errors. So I really like this for defining your request contract. You deserialize the request JSON maybe into your request struct, and you ask it if it's valid. You can push that into your framework so that you don't really even need to think about it. You can just have that happen for all of your request structs. It supports nesting compose structs as well. So maybe a customer has an address. You can define validate on the customer and call validate field and pass it just the address with no rules, and it'll call all the validation rules that are defined on the address struct. So what is validation required? What is, like, when you say validation required as an argument, what is that? What's happening? Internally in the package, it's just a struct. There's some rules inside the package that say how to do that validation. Interestingly, I think you could implement this instead. If you wanted to write your own, you could maybe use required could actually be a function that gets called later to actually do the actual validation, maybe. And then supporting custom validations is really easy. They've provided you this by format which lets you define your own validator as a function. So it just has to match the format of value interface and return an error, and you can write whatever you want. And if you return an error, the validation fails. Okay, so where do we put this?
One question.
Yes, yeah.
Do you have any examples for cross-field validations? Let's say password cannot contain or be equal to the username, or number one must be larger than number two, and blah, 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 all this kind of thing.
Yeah, so I think if we're talking about the OZO validation package, I think you're going to run out of their validators support for those things really quickly. You'll end up writing your own custom validation. So you would have a validation cannot use username for email or for password or whatever. And then you would call that. There's actually, they have a neat way to pass multiple validations here. I mean, they're just arguments. Like you can just pass a slice of these validations as an argument here, and it'll execute each of them. So you could build up like a complex group of validate rules that define some validation for your field, and then pass that, reuse it if you want. I think I'm getting repetitive here, but yeah, request validation, validating client contracts, model validation. Put this as model validation as a supplement to or extension to the DB validation. I think I talked about this already. Yeah, if you're using Mongo in the back end, it's not enforcing a whole lot for you. So I really say you probably want to do something like this. And depending on what kind of framework you're using, if you wrote your own or whatever, your save functions can automatically call your validator and kind of enforce that validation for you before you write your structs back to the database. I think once upon a time people would have said that implementing your validations in the model layer and not in the database was leaving you open to some problems, like what if there's another app using your database, now it doesn't have your validations, they can insert bad data. But I think we've kind of, I'm open to opinions here, but I think we've kind of come beyond that a little bit. I think the common thinking is that applications kind of own their own data, and if you want to work with that data, you have to go through the application as a gatekeeper to that data. So really that means going through the API instead of reaching into the database. Yes?
I'm sorry, I'm just ignorant on this. Is it common that key value stores, Mongo, Redis, those sort of things, don't have validation, like the option to do validation on their data? Or is Mongo an outlier?
I don't know. Has anybody actually used validation on Mongo?
I think there is validation within it.
I suppose.
There's a mechanism for it, but it doesn't enforce it.
Ah, okay.
It's like, maybe, So, yeah.
Yeah. I don't know. In all the projects that I've seen that have used Mongo, none of them have written validation on top of the database. Like, if it's there, it's in the application layer, and usually it's not there. So.
I think they recently have you could use JSON Schemas to validate.
Okay.
But it's
Yep.
not great.
Okay. Excellent. That ties into what I was going to say. Okay. Perfect. Yeah. I think nowadays people expect that if you want to share data between two different services, one of them owns the data. You have to talk to that service's API, and that service is going to enforce your validation for you. So.
Well, I get microservices. Each microservice owns its own data source. And
Yeah.
That's it. So.
Yeah. Exactly.
So
Yeah. Exactly. Each service microservice owns its own data. Yeah. Okay. So what do we want in a simple validator? Do the packages we looked at meet our needs? Well, I mean, again, this probably depends on the size of the company that you work at. If you work at a small company, I mean, I think these probably look really good. I think if you work at a company with 100, 200 developers, these might come off as a little overly simplistic. But sticking with the small startups, what do we want in a simple validator? Well, we want it to report on all errors, don't fail in the first one, standardize how we deal with validation errors. That's sort of left up to the user, I think. The client can intelligently act on the error responses. We saw how one of the packages exposed the ability to send the errors back as a map with the field name in it, so you could do something reasonable with it, like highlighting the offending fields or displaying inline errors. Okay, so building on that, what can I get for free? Okay, so I've adopted your idea of request contracts that can validate themselves. What else can I do with it? Why should I really go with this? Well, the formalized contracts are your documented API. In fact, you could even use the validation framework to generate the documentation for your API. Nobody likes writing API documentation. You get separate formats for the client contract and the DB model. That in smaller apps, you might, the user that you serialize to the database might be the same user struct that you send and receive from the clients. But as you grow, you kind of want the ability to separate those two, and the ability to change the underlying data structure without breaking support for the existing clients, or add a field to the client support who says, I really want this field to exist, but it's a calculated field. It doesn't need to go into your data source. So, like, having that flexibility is useful. Which is what I just said. The contracts, I didn't show you this, but the contract can implement to or from functions. Like address can say to model address or from model address and be able to translate itself back and forth between your internal DB model. And I think this is the right direction for the dependency to go in. It's easier to version your APIs. You can just create a new contract. And hopefully you get data consistency. What else can you get? Well, you can use your validation framework maybe to generate a JSON schema for you. Dynamically generate, using your JSON schema, you can dynamically generate forms on the client side. So, okay, I have static fields. Why do I need dynamic form generation? Well, there's maybe some interesting things you can do with a province is one of a certain set of acceptable province values. Well, if you pass that information to the client can include that in the drop-down and it'll be exactly in sync with the server. You won't ever end up with a situation where the client side has a select option in the dropdown that the server rejects because the two aren't in sync. You can implement all the same validations in JavaScript on the client side, or in whatever, on the client side, and because the rules have nice normal names with simple arguments like min size or min length 1 and max length 10, the client has a short list of rules that it can implement and basically mirror the validations on the server side. So if you think about this, this means that your client is always in sync with the validations that your server has. It's never going to allow or reject something that the server would not allow or reject, and can perform the validations in JavaScript without ever talking to the server. So you get rich, immediate inline errors with immediate feedback. So you hit save, and a couple milliseconds, you get your error back right away.
With the exception of uniqueness and stuff that we got.
With the exception of a few things. The exceptions are uniqueness, like you said, you can't check on the client side, and also if you have complex custom validations, they'll be too complicated for the client side to implement, at least if they're not built from simpler types. This is an exercise in like creating your own custom validator. Now that you've seen all the other packages out there, you're like, yeah, they're great, but I could do better. So what would our own perfect validator look like? Well, I don't know. I'm just making this up, but maybe it follows a similar pattern as we saw before, except there's the validator passes itself into the function, removing the requirement to re-reference the package over and over again. This is actually really important if you do want to do schema generation, because then you can build up state from the document that you're validating. I got support for the string in list here. I've also got support for default and title here, which are kind of JSON schema ideas that the schema gives hints about details about the field. So in addition to the type of the field, that this is a string field, it also says, hey, this is the default value. This is the label that you want to use when you display it on the form, things like that. So the advantage here is your validator can build context, output the schema as a side effect. I thought about this a lot, and oddly, and I think default actually might be better to separate the validator from the schema builder. I'm kind of torn on that. What you can example of the output of what you can generate from this is very similar to what the JSON schema spec is. You can say, here's my user. It's got this name field. The name is a string. These are the rules. The rules vary a little bit from the JSON schema, the official JSON schema spec, if anybody's interested. But it varies a little bit. But you can say, these are the rules that I've implemented. This is what the client would need if it wanted to implement it on the client side. The province type is a string, but it has to be one of these values. And you can pass those values to the client, and the client can use that as to build combo boxes or do client-side validation or whatever. So the schemas we saw with default and title there, that can be passed into the schema, either for generating UI or providing tooltips or whatever. I think that's kind of it. That's my tour of validation, as I've been thinking about it for way too long. Questions?
Sorry, yeah, I have
Sure.
a question. So do any of the tools that you kind of covered here provide any sort of mechanism for getting kind of more meaningful errors when some of these validations fail. Like, so say it's like a big string or some sort of big object. Like, do any of them provide like a tool to like diff why something has failed, or anything like that?
I'm just going to repeat the question. The question is, do any of these tools provide the ability to diff the...
Yeah, like, so if you wanted, so you're running it through a function, right?
Yeah.
That's kind of like saying, is this okay or not, right?
Yeah.
But beyond just saying, okay, is it okay?
Yeah.
Do any of these tools give you a way to kind of return why? Beyond just maybe just a string?
Okay, so do any tools give you ability to return why it's failing? Yeah, I think the answer is yes. I think probably with the exception of the function validators, which was the first example, which kind of are a little too simplistic. You'd have to build on top of that. The rest really try to give you a list of errors or a map of errors or some more complex structure of errors that say, this field, the user email field has an issue, and the issue is specifically that it doesn't have an @ sign. So that's incidentally, that's actually one reason why you maybe wouldn't want to use a regular expression validator, is because the regular expression validator can really only tell you that it failed, not why it failed. Whereas if you use, if you compose an email validator out of these smaller validator types, like splitting on the @ string and like looking at the domain and different parts of it and checking for valid character sets, you can actually provide a really detailed answer as to why the email address is invalid.
Cool.
Yes?
You mentioned earlier that you can get kind of documentation based on your validation. Is that something that you could get for free, or would you have to build something to kind of enable you to pull out the validation rules and drop it in the documentation?
Do you get the document for free out of the validation? At this point, I think there isn't anything out there that I've seen that will give it to you for free. I think if you go to like JSONschema.org, there's an effort to kind of document what a JSON schema looks like, and the Osmo validator is a really good start towards doing that, but it's missing that last step of keeping the context of the fields in the document and building that schema as it goes. I have built this in the past. It's not open source, so I would actually be interested in building it again. So if anybody thinks that this is really relevant for what they're doing, I'd be up for collaborating on something. Any other questions?
So, yeah.
Okay.